All right, we're going to do 4 examples today. These first 2 have another way of doing them, a trick to do them a little bit more quickly than doing factor theorem and factoring the way that we did a couple days ago and have just been talking about. You don't have to use the trick. Okay, so you could still do the whole long way of going hunting for a factor, synthetic division. Notice that first one would have some ghost terms in it. Like, you'd have to notice that. If you miss it, things are going to fall apart. So why do we care about the trick? Well, it's faster. Problem is it doesn't come up that often, especially the first one. So, don't spend hours and hours and hours trying to figure it out. That's not probably worth your time. But if you happen to be good at noticing patterns and you notice it, it'll save you a lot of time. You'll see when we do it how much easier it is to factor it a different way. And same with B. It's got a different way that we can factor it, which doesn't come up that much. You learned it in grade 10. You learned how to do both of these in grade 10, in fact, if you took grade 10 at this school at least. It doesn't come up that much until calculus. And in calculus, it looks a little bit different, but we start using the method a lot for part B. But when we get there, if you take calculus, we'll go over it in a lot of detail and you'll practice it a lot, so you'll be fine with it, even if you don't kind of pick it up right now.
On the test, are you ever going to give us one where like factors like 10 or something super high where you got to keep?
Generally speaking, no. Just anywhere is fine, thanks. The only time I could imagine doing that, and I don't think I've ever actually done it, was like, what if it was 13? But 13 is prime, so you try 1 and -1 and then 13 and -13. But if you're not paying attention, what would you do? 1, -1, 2, -2, 3, -3. But all of those don't work. Like, you should know all of those don't work because 13 is prime. I suppose that's fair because we've talked about it. But would the final number be 24? And you got to check 1, 2, 3, 4, 6, 8, and it's none of those until you get to like 12 or something? Typically not. You're going to find almost every time between 1 and -2, you're going to find, okay? But, there could be the odd one you have to go to 3s. So it could happen, but not generally past that. I'm not really interested in wasting your time going through all of it. That being said, later, not yet, but later, I'm going to show you a trick with your calculator where you can get your calculator to do this very quickly. And in that case, maybe it's a bit more fair to give you more options. Not right now. So what are these tricks? Oh, and then we're going to do 2 others that don't really have a trick, but they're things to point out. And one of them is really just more practice. So we're going to do these 4, like I said. What are these tricks? What do you notice about that one? Yeah, Mohammed. It's got 2 ghost terms. It's missing 2 terms, the cubed and the linear term, the degree 1 term. It's a trinomial. And this one actually is set up in a pattern of a simple trinomial. So don't write this down, just watch. If I wrote this as x squared minus x minus 12, could you factor that? What is it? Come on. Graham? Huh? So x minus 4, x plus 3. Yes? Everybody agrees with that? Well, it turns out that there's the relationship for simple trinomials in quadratics where the first exponent is double the middle exponent. That pattern holds as long as it's double. So if this is a 4 and this is a 2, I can factor it the same way. If this was a 6 and this was a 3, I could factor it the same way. If this was a 1 and this was a half, a half would be square root. I could factor it the same way. It would still work. As long as you have a variable term constant, and within those 2 variable terms, the degree of one is double the degree of the other, that will work. So the numbers are going to be the same. But x times x doesn't give me x to the 4, so what do I have to do? Yeah.
And x outside the brackets?
No, it's not a common factor because the 12 doesn't have an x, but that's a good guess. Yep, that's
We
right.
have both of the x's.
If they're both x squared, I get x squared times x squared is x to the 4th. I get 3x squared minus 4x squared, which is negative x squared. Right? It's the same pattern that we get from a simple trinomial that results in a quadratic. Okay, if I expanded those two brackets, I get a quadratic, but in this case I get quartic, but it works out the same. This is the one that, to be honest, doesn't come up that much, but you never know, and if it does, isn't that a lot faster? Right, we're done. No, we're not done. What did we miss? We're almost done, Andrew.
Different to squares.
Yeah, but you'd have to do that one way or another anyway, so, whoops. Okay, what do you think? Like I said in the opening, you could go hunting for a factor. What would you find? I guess you'd skip over the ones. They wouldn't work. You can kind of tell just by looking at it, and you'd get to positive 2 and it would work. Synthetic division, figure out what's left, go hunting, you'd have a cubic, go hunting for another factor, you'd find negative 2 would work, wouldn't be that bad. But more steps. Okay, next one. Does anybody recognize this? Every few years somebody does, but that surprises me. I don't expect you to. You do it in grade 10 in the factoring unit, and then you barely see it again, and you only do it like a little bit, and you do so, it's funny, when you do so much of the other kinds of factoring, trinomial and common factoring, you forget about these niche, more obscure instances. Anybody? Factor by grouping. Oh, were you going to say that? Remember that? Factor by grouping. So I group the first two terms and factor them, group the second two terms and factor them. You can reorder sometimes, but in this case we're going to leave them the way they are. And then there's another step after that, which is a little weird, and that's the part where some people have a hard time with this. But once you've done it a bunch of times, and now that you're 2 years older than grade 10, you probably won't find it as weird as you might have in grade 10. So I'm going to look at the first two terms and common factor them. What's common factored between x cubed and x squared?
X squared.
So I take x squared, x squared, and factor it. Easy so far, right? Now the trick is, I'm going to common factor the second two, but they have to factor in a way such that the bracket that I get is also x minus 1. If you can't do that, then it's not a factor by grouping question. And this goes all the way back to when you first learned how to common factor. And the questions you're given are just, you factor it fully. But now it's like, no, we want to factor it in a convenient way to give us what we want. So what do I want to factor out of those two terms so I'm left with x minus 1? Andrew? I want to factor out the negative 4. And this is really important because I would imagine somebody in your grade 10 class, we used to do a bit of common factoring in grade 9, but it's been a long time, so you wouldn't have done it in grade 9. But in grade 10, when you first see it, probably somebody in your class asked, do we have to factor out the negative? And some teachers say, yes, it's a rule, you have to. And some teachers say, no, it doesn't matter one way or another. But again, honestly, the answer is, you do if that's what makes it work. You do if it's convenient to get what I want. If I didn't want it to be negative in the bracket or whatever, then I wouldn't have taken the negative out. But in this case, that's the only way we get two brackets of x minus 1. Does that make sense? So more and more now, it's less about rules. You have to take out the negative. No. But sometimes it makes sense to, and you want to. It makes your life easy, or it's what is going to make the whole thing work, and you have to recognize that. Okay? And here's the step that back in grade 10 might have been a bit tricky, but once you've done it a couple times in grade 12, you should be okay with it. I like to do it this way. I write that bracket that they have to be exactly the same. They're both x minus 1. I'm going to write that first. And then I'm going to write my second bracket because we are factoring, so it's got to be in factored form. And I just write all the other junk. So in this case, it's x squared minus 4. So the x squared term that was out front of the first part and the minus 4 that was out front of the second part. So write the bracket, and then in a second bracket, write the other junk. And we're done. No, we're not done. So we're catching on to this now. So we got another difference of squares. You may or may not have that. It's nice that it comes up to remind you, always look at the very end to see if there's anything lingering that can be common factored or different squares or something else. You get caught up in all the hard stuff and all the new stuff that we're doing in grade 12, and you forget about the grade 9 or the grade 10 stuff, right? Because you're like, I did it. I got it. You're like, yeah, but you're not actually done yet. There's the easy stuff left, right? So proud of yourself for seeing that it was a factor by grouping. You're like, yes, I got it. And then you forget that there's actually a little bit more to do. So be careful of that. Another thing that I really want to warn you of is, in the last couple of years, I never had it before, but I had a few people who, for whatever reason, I don't know why, because I didn't say this, think that everything is you can do factor by grouping. Oh gosh, no. Most of them don't work that way unless I set it up that way in the question. It's the only time that happens. So don't try to use that method on everything. People do it and they don't get the same brackets, or they force it and it doesn't make any sense. There's mistakes all over the place. It's 0 marks, like it's just a disaster. Factor theorem that we did previously is what you will usually use. This is a special case that might at most come up once on this test and maybe another time in the course, but that's about it. Okay, so don't obsess over this and think you can always do it. Any questions? So trinomials, that pattern where the highest degree is double the middle term or the next highest degree and then constant, it's a trinomial. You can still do it that way. If it was a complex trinomial, you could still do it that way. Factor by grouping. Two other little techniques that you could do. So this is a degree 4. I guess it's worthwhile to check and make sure there's not another higher degree hiding in there somewhere, but I don't typically do that in the factoring part of the test. We did that with N behaviors on the quiz, if you remember, where one of them was written out of order. That's common. I don't try to trick you in these ones typically, so they're usually written in order, because that would be problematic. So this is degree 4, and you hopefully are already getting familiar with, so you got to find a factor, synthetic division, let g at x equals, find another factor, synthetic division again, because every time you do that, you go down 1 degree. So we start at 4, we go down to 3, then we go down to 2, and then we can do the trinomial factoring. But there's something about this one that's different, isn't there? Did you notice it while you were writing it down? No constant. So there's more to that. You're right. What does that mean we can do? We can common factor out maybe a 2x, but in this case it's just x, and make our life a lot easier. So we only have to do factor theorem once, because when we common factor out the x, we're going to bring it down to a cubic that's left over, and then we only have to do synthetic division once. So look for that. Oh, this is the other thing that I forgot to mention. in the learning goal, but it comes up right here, so that's perfect. Some people in the learning goal, when you have an actual degree 4 and you have to do the synthetic twice, they write that factor out the first time, but then when they get down here, they stop writing it out. And I warned you about this, but a couple people did it, so be careful, okay? You have to, that x plus 1 that came out here, you got to keep writing it every time. So I circled that on your page and hopefully you figured that out, but that is important. It's a common mistake early on. Later in the course, probably you won't keep making it, but it is a common mistake at this point, so be careful of that. And it's even more so when it's just x, because you just kind of think it's not as important moving forward. It absolutely is. And we'll see a lot of why it's important in the next unit, even a little bit in this unit. Okay, that almost looks like a factor by grouping to me, because you've got like a 27 and a 36. They're both divisible by 3 and by 9, but this one doesn't work out that way. There is no way to divide both of them to get the same bracket. So it's not, so we're just going to go hunting for a factor. Is 1 going to work? Nope. You got 2 negatives that are really big and 2 positives that are really small. 1's not going to work. What about negative 1? Because that's going to flip the 27. Well, it's still not going to work. The 36 is too big. 27 and 1 and 2 is 30. So even if all those had the same sign, they still don't add up to 36, so that's not going to work. If you don't follow what I'm saying when I'm talking about this stuff, it's okay. You can just use your calculator. But again, once you start to do more and more of this, you'll see, you start to see these things and pick up on them, and you can save yourself some time. Anybody figure out what works? Two and negative 2 don't work. 3 doesn't work either, but negative 3 does. Somebody asked the other day how I was skipping those. Like, what was I doing to skip those values? And I bet there were other people wondering the same thing. And I think I mentioned it, but there's a lot going on, I know, so you missed the odd thing that I say. I've got it written down beside me. I know what the answer is, so I'm trying to save us some time so that you can practice on your own and ask questions and that kind of thing. That's how I know that 2 and negative 2 and 3 don't work, because I've done it in the past, and I'm hoping that you're on board with what that procedure looks like and you would be able to do it on your own, but let's bypass that and not waste our time doing it right now, because you're going to do a lot of that on your own later. So this is what I was saying before. You got to write this. Therefore, x plus 3 is a factor. Say that line exactly like that, and you will be safe. Don't forget the x. Then you got your x plus 3. Then we're going to get a quadratic. Factor that, we're done. Okay, give that a try. Quick second at least. Everybody okay? I hope that's a straightforward tip. If every term has an x, factor it out. If every term has an x squared, at least factor out x squared. Okay, last one. If you want to just go ahead and try this one on your own, there's not really a trick to it. I'm gonna jump start it for us anyway, but go ahead. There isn't a trick to this one. Something happens later, but we've already talked about it. It's just a bit of a reminder and review. If I look at the ones, I don't know, I'm not convinced without actually adding things together, because I've got negative 20 and positive 29, and negative 20 and negative 4 and negative 12. I mean, that's close-ish to 29 and 4. But it's not equal. So it doesn't work. But it's close enough that you have to actually do the adding to figure out that they're not equal, right? So there's some times where one of the numbers is so big and it's the only negative that you can tell just by glancing at it it's not going to work. This is a case where it's close enough. You kind of have to either do the math in your head or pull out your calculator and add them up anyway. And then flipping the signs, I think you would notice that's not going to help at all. In fact, you're going to make almost everything positive, so that's going to make it worse. So 1 and negative 1 don't work, but positive 2 does. Oops. F, nope. Okay, even if you're not quite there yet, just pause what you're doing for a minute and watch. This is a situation that I was talking about when we were taking up the learning goal, and we have seen it before, but I'm going to point it out again now that you've been practicing this for a little bit. Okay, this is, I've got the results of the first factoring. Let g at x equals that. Where do I start testing again? Yeah, so we test 2 again, not the next, don't go to negative 2. We test 2 again, because it could still be a factor. If 1 and negative 1 were not a factor of f, and if I did that correctly, they will not be a factor of g. Okay, they can't be. It doesn't make any sense. If you don't remember why we talked about it, or if you didn't understand it, trust me. Okay, guarantee it's true. So, what happens here, some of you have already done this, we get g at 2 is 0, therefore x minus 2 is a factor of g. So we get f at x equals x minus 2. That was the first one from above. And now our next x minus 2, which you could write it as x minus 2 squared there. I'm not doing that just to help you kind of see what's going on. But absolutely, you could write that as x minus 2 squared. This is the case where you have to, for full marks, say let g at x equal that, g at negative 2 equals 0, therefore it's a factor. If you said f at positive 2, equals 0, therefore it's a factor, yeah, you already said that. You're saying it's a factor of f, not a factor of that, right? So that, it would be minor, you'd get the right answer probably, but for full marks, you have to show me that. So just be careful. Okay, now you can go ahead and finish that question, and then that's it. You have the rest of the period to keep practicing and keep working.